the more information you'll receive. If you log at debug, you'll receive all messages info and higher. If you log at info, you'll receive all messages info and higher, and right up the chain up to emergency. So if you log at the critical level, you will not see error down to debug, but will see critical up to emergency. And that's how syslog facilities work. So with that said, let's discuss targets. Targets tend to be the following: file, such as varlog messages; TTY, such as dev console, or even dev TTY1. The dev console will report to all consoles, all connected consoles, as well as remote hosts indicated with the @ symbol and the IP address of the remote host, which provides a means for you to log information across the wire using UDP. So again, let's step back and just imagine how syslog messages are routed. The daemon receives messages based on facilities. Facilities are tied to applications, daemons, network devices, etc., and there are many facilities. Each facility supports 8 levels, 0 through 7, with 0 meaning more information, 7 meaning less information, but more important information. Once the information has been parsed, it needs to be sent to a target, either a file, a TTY, a remote host. You may optionally send to multiple targets simultaneously by indicating multiple rules, or specifying on the right-hand side of your rule multiple targets separated by commas. You may also specify multiple facilities and levels on the left-hand side by delimiting them by comma, which leads us back to the etc.syslog.conf file. Notice for this first uncommented rule, the facility is undefined, or it's defined as all using a catch-all asterisk, meaning any facility. So asterisk equals catch-all / wildcard to mean any facility or level, depending on where it's specified. In this particular case, star.info means any facility at the info level will ultimately be logged to varlog messages. With the exception of mail-related messages, anything .none means not to log, as well as authprive.none, as well as cron.none. So let's just indicate as well that .none equals rule to exclude, or exclusion rule. When you see .none in a rule, it means to exclude those messages. So if a message comes in at any facility with the exception of mail, which means mail-generated messages, authprive, and cron at the info level, those messages will be sent to varlog messages. Again, back to our levels 0 through 7. If a message comes in at the info level, which is level number 1, it also means all levels 2 through 7 will be recorded. Not debug, however. Just info up through emergency, which is a pretty low level to begin with. This also explains why the varlog messages file tends to be populated with a lot of information, because it expects and logs information from various facilities, minus what we saw, mail, authprive, and cron, at the info level, which is pretty verbose. Let's continue exploring the rules. Now, we did mention that authprive nothing goes to varlog messages, which means if you authenticate using a facility that logs using authprive, such as SSH, don't expect to see the message in varlog messages, at least not on Red Hat Enterprise. However, below we see authprive.star, which means the facility .any level, which means any level from debug through emergency, will end up in varlog secure. So when you do authenticate to this enterprise box, expect to find authentication-related messages in varlog secure, and a separate window will confirm that. Let's navigate to varlog and LSL secure, and there we see the file secure, and if we are root or root equivalent, we will be able to examine the contents. And here we see all of the SSH instances, user deletions, and anything that would make use of the authprive facility. Let's move forward. Messages for mail. If the facility is mail, regardless of the mailer, postfix, qmail, send mail, and the level is anything. That's what the wildcard means. The message is sent to varlog mail log, and it's synced on disk to improve performance, since mail logs tend to be pretty big. Cron-related items. Whenever jobs are run via cron, cron makes use of the cron facility. It's a reserve facility, and all levels of cron will be logged to varlog cron. Any facility that reports at the emergency level will be sent everywhere, which means everywhere possible, all of the TTYs, as well as all of the possible open log files such as varlog messages and so on. For news, we see UUCP, news, at the critical level and higher, gets logged to varlog spooler. And local 7 is the bootlog route or router. Now what about various facilities? What facilities are available to us? If you man Syslog or man syslog.conf, you'll get a sense for the supported facilities and levels. Let's just note that. Man syslog.conf to learn about the supported facilities and levels. So back to our shell window, and you'll see, for example, the following facilities: authprive, auth, cron daemon, kernel, LPR for printing, mail, mark, news, security, which is the same as auth, syslog, user, so on and so forth. When you're logging from a network infrastructure device, chances are you're going to make use of the local facility, for which local 0 through 7 are supported. But from our configuration file, syslog.conf, we know that local 7 is being used. Let's cat the contents of etc syslog.conf once more just to refresh your memory, and you see local 7.star contains boot items. So we really have available to us local 0 through 6 for rerouting, let's say, foreign devices like networking devices. Additionally, the syslog.conf documentation includes the various priorities, which we've described, from debug all the way through emergency, or 0 up through to 8, up to 7 that is, for 8 levels. So there's no need to memorize the different facilities and levels. Here are the actions. This is what we call targets. You can send to a regular file, to a main pipe, to a remote machine using a prefix of @ to a list of logged in users, to dev console we saw above. It's pretty straightforward. On the left hand side you have your rule, and on the right hand side you have your target, which your documentation labels slightly differently as actions. So with that said, let us make a modification to our infrastructure device, the Cisco router, to cause it to log to the local system, which will cause us to have to do a couple things. So our first task is to enable logging it will enable UDP logging, which means internet socket logging, for remote Cisco gateway, which is located at the following IP address. This is a multi-step task because first and foremost we need to set up the pristine syslog configuration to listen to UDP port 514. To confirm, we can use netstat NUL grep 514. This reveals UDP 514 listeners, or listeners, since there can only be one listener at a given time to a given socket. So let's try this from the shell to see if it's listening, and there you see grep returned nothing. And a netstat NUL will return all of the UDP listeners, but 514 is not enabled. We need to enable it, and it's disabled by default for security reasons. So step B is to nano the etc sysconfig. Sysconfig is a repository for startup configuration files for daemons within Red Hat Enterprise Linux. And we'll modify the syslog file in etc, and this is the syslog config file, we mean the sysconfig syslog configuration file. We want to alter the syslog startup options to include -r. -r ensures that the service, when restarted, binds itself to UDP socket 514. So modify etc sysconfig syslog and include the -r option for the variable syslog d underscore options. So append or set syslog d options equal to -r as an option. And it's between double quotes, so let's just indicate as such. And then, of course, restart the syslog instance. Restart syslog and confirm UDP 514 listener. If we don't follow these steps, or if we don't enable UDP 514, we will be unable to log from across the wire. So we'll turn on -r, then exit. The M0 ensures marked messages are turned off so they don't appear in the logs. And then we will execute service, and service is a facility provided by Red Hat to ensure that you can manage your services, starting them, stopping them, restarting them, and so on. And we'll execute syslog, restart. Again, no need to memorize the service name. If you take a look at etc in lit.d, where the initialization script resides, syslog, this is the name of the service that you pass in to the service command. So service syslog restart restarts the service. Now let's re-execute netstat NUL. We will find that port 514 is available. We can grep it out to suppress the output, and there you see 514. And if we turn on option P with the netstat command, you'll see that syslog D with process ID 6202 is responsible for 514. So now syslog will accept messages from remote devices or remote syslog capable clients, whether devices, other operating systems, what have you. So the next step, now that we've confirmed it, and we'll just list this as C1, confirm using netstat NUL grep 514, and it should return the syslog listener. The next step is to configure the router. So step D, configure the router, which means we'll need to SSH into it and enable the appropriate level. Now we know local 0 through 6 are available. We need to pick one, perhaps local 0. Configure the router using facility local 0 and level info so that we get a lot of information. Then step E will be to configure syslog.conf, that's etc syslog.conf, to accept local 0